I'm Kirk Harnack. On This Week in Radio Tech, hey, Chris Tobin and Tom Ray join me, and our special guest, Curt Yengst. For a War Stories episode, Kurt's been through a hurricane, and the funny thing is, he had several years to prepare for it. It's pretty interesting. It's up next on This Week in Radio Tech.
Netcasts you love.
From people you trust.
This is TWiT.
Bandwidth for This Week in Radio Tech is brought to you by Cachefly at CACHEFLY.com.
This is This Week in Radio Tech, episode 130, recorded May 23rd, 2012. War Stories. This Week in Radio Tech is brought to you by Telos and the Telos ProStream, streaming in a convenient appliance. On the web at telos-systems.com/ProStream. It's time for This Week in Radio Tech. Hi there, I'm Kirk Harnack. I'm so glad that you're with us. I love doing this show. Every week, week in, week out, this is a fun bunch. Yeah, the pre-show is great, and sometimes the after-show is great. It's always good to have the banter with Leo. So if you're watching us recorded, like you may be now, hey, why don't you tune into the TWiT Network live? Just to give a quick plug, before TWiT is live on the TWiT Network on Wednesday afternoon, evening, depending on where you live, is a show called Triangulation. And Leo Laporte and Tom Merritt are the hosts of that show. They always interview somebody fabulously interesting. So you can tune in for that show and then hang in for the banter and the show after the show and then the show before the show and then our show. You got that? You're going to enjoy it. This Week in Radio Tech is a show where we talk about radio technology, audio stuff, everything from the microphone and acoustics to audio processing to the transmitter to the antenna on the top of the tower. Let's see who else is here to join us and chat this week. By the way, it's a War Stories episode, so we're going to tell some crazy stories, real-life stories, all the truth about radio engineering in the trenches. And a guy who's been in the trenches a lot from the Hudson Valley of New York. Let's bring in Tom Ray. Hello, Tom. How are you?
I've tried not to be in the trenches, but, you know, sometimes you just end up there and, hey, what can I tell you? It depends on what you drink. Hi, I'm VP Engineering of WOR in New York City and Buckley Broadcasting. I'm a ham, and, hey, I'm here. What more can I tell you?
Glad you're here, Tom.
I'm here to have fun.
You take care of this big honking AM transmitter in New York for WOR, right?
Oh, yes. Oh, yes.
And then some FMs at some other Buckley stations, right?
Yes, sir.
And you know, I've always appreciated, Tom, that you tend to step out and take a little step on a branch to the cutting edge of technology. Sometimes, you know, it burns, it cuts, you bleed a little bit. And sometimes it works out right, and sometimes you can say, you know, I just found another way that doesn't work.
Yeah, exactly. And you know, unless you take that, you know, if you don't take those chances, you don't learn. We don't advance our art, and what we do is art. I mean, let's face it. Not everybody can fix a transmitter. Not everybody can make an antenna work. And hey, my goal in life is to have fun, and I have a lot of it.
All right, thanks, Tom. And also with us is from Manhattan. I call him the best dressed engineer in the country in radio. It's our friend Chris Tobin. Hey, Chris, how are you?
Hello, Kirk. Tom. I'm doing well. I'm president at CCS Musicam. For disclosure, we do IP codecs, both in video and audio. And I've also spent 20-plus years working radio and television, recently with CBS Radio Group. And I, too, am a ham operator and enjoy tinkering. And I had the chance and pleasure of working on many high-powered transmitters, both AM and FM, in most strange places, tall buildings, large fields. And it's been fun, and I continue to have fun. So that's where I stand. As with Tom, I enjoy a good drink. Is my wine from Spain, España, and I like to have fun and enjoy life.
In fact, tonight I'm drinking water brought to you by Brita, or maybe it's Pure. Ooh. I forget which, but it's yeah. All right, and then we have a guest. Chris Tarr is taking the evening off. We have a terrific guest with us. This is a guest that Chris Tobin suggested that we bring on the show. In fact, this guest recently wrote an article, I believe in Radio World, but please correct me if I'm wrong. Let's go ahead and bring him in. Curt Yengst. Curt Yengst from WAWZ. Hey, Curt, how are you?
I'm doing all right. Staying out of trouble.
Glad that you're here. Why don't you tell us a little bit about yourself? And within a few minutes, we're gonna kind of foreshadow your story. So go ahead and tell us about Curt Yengst.
All right. I'm assistant engineer with WAWZ. I've been in that position for about the last 6-7 years. I have worked for them previously as a board operator and announcer back late 80s through the mid to late 90s. Did some recording and production work for the Billy Graham Evangelistic Association back in from about 1998 to 2003. Worked for Blue Ridge Broadcasting in Asheville, North Carolina for about a year and a half. And here I am doing what I do best.
And WAWZ, I was looking up a few things about your station that you're working for now. It's a contemporary Christian station, but you guys try to hit a big audience. I get believers and non-believers because you couldn't tell it much from a top 40 CHR type of station. Am I right so far? Have I got this sort of right?
That's about right. Yeah. Mm-hmm.
The station was founded in 1941 by Bishop Alma White and the Pillar of Fire Church.
Actually, it was 1931.
Oh, 30
was when the station was when the station first went on the air. We have a sister station in Boulder. No, not Boulder. It's outside of Denver. I can never get the name of the town right. Outside Denver, Colorado, we have an AM station, KPOF. They went on the air in 1928, and then we have another station in Cincinnati that I think went on the air sometime in the 50s or 60s, which makes us, technically speaking, the oldest Christian radio network in the country.
Oh, okay. Wow. So, the war story that you've got to tell, let's foreshadow this just a bit. You want to set it up for us? Tell us what we're going to be hearing about, what acts of technical daring do and bravery we'll be hearing about as we move through the show.
Okay. The station is located, was located in the small community of Zarephath, New Jersey, which is right smack in the middle of Somerset County, right smack in the middle of the state of New Jersey. It's also right smack in the middle of a flood zone. So it doesn't take much. We're about 60 feet above sea level. And
now, wait, is this the studio or the transmitter or both together?
This is the studio site. The transmitter is in nearby Martinsville, New Jersey, a good 600 feet above sea level. We have the Delaware and Raritan Canal running in front of us, and then we have the Millstone River running behind us. So when you get a good nor'easter or a tropical storm, or in our case, Hurricane Irene, when that comes through there, it can make for a bad weekend.
So that's what your story is going to be about, Hurricane Irene, and what you guys ended up doing in preparation for a storm like this.
In preparation for that, but also based on lessons learned from previous storms. About the time, it was 1999 when Hurricane Floyd came through and did every bit as much damage as Hurricane Irene. That was before my tenure as assistant engineer, but I was still in touch with a lot of the people that worked here, so I knew secondhand what was going on there when Floyd came through. And then in 2006, late 2006, we had a nor'easter come up through. Didn't do anywhere near as much damage, but it certainly made the place inaccessible because Weston Canal Road, right out in front of the campus, can get flooded very easily, where it's running parallel with the canal for about 3 miles. So it doesn't take much.
We're going to have some pictures, I think, a little bit later on in the show. But so we've kind of foreshadowed here preparation for a disaster, and then how you handle it during a really bad disaster, Hurricane Irene. And we've just after Irene, we talked to a couple of engineers about what they did. In fact, Tom and Chris Tobin had some stories too. But we're going to hear Curt. I first heard about you from an article that you did in Radio World magazine. Was it Radio World? Have I got that right?
Yeah. Mm-hmm.
Okay. And what prompted you to get your story told that way?
I had written for them previously when we were talking about studio renovations and things like that. And, of course, after we kind of got over the initial disaster cleanup, I thought, yeah, they might like to hear this story because it was kind of an interesting story in that we had already in place a backup studio at our transmitter site. And I guess we're going to get into that as the program unfolds. So I floated the idea. I said, we've got plenty of pictures. We got a lot going on here, a lot to cover. And my editor at Radio World, Brett Moss, he jumped right on it, and we gave it a go.
All right, that's good. Hey, and Chris Tobin, listen, you brought the idea for us to talk to Curt. What did you know? Do you know Curt before this all happened?
No, I did not. I mean, I drive through that town that his studios are now in, Somerset, quite often for business, but that's about it. No, I read the article. I could relate to a lot of what he went through, and I said, gee, this would be a great topic and someone to talk to on the show. And I just reached out to him, and he was more than happy to oblige, and here we are.
You know, I have been anticipating this show with Curt for a couple of weeks now, and I just realized I just totally forgot to prepare a war story for this episode, so I may have to work on that while we're talking here. But I want to pass it around to Tom and to Chris Tobin. The War Stories episode is where we talk about something that happened that was kind of dramatic, perhaps, maybe a really teachable moment that came out of it, and that's what Curt Yengst is going to have for us, because they prepped and they were prepared, and then they were able to be on the air when without the preparation they wouldn't have, and that's a lot of what broadcast engineers. It's part of our job. It's part of our job to persuade management and ownership that preparation is important, that we need to set aside funds, time, backup locations, that kind of thing. So, when disaster does strike, we can, as engineers, keep you, Mr. Broadcaster, on the air. I'll tell you what, I will tell you something briefly that's been happening. We're going to go more in depth in this on another show. You may know from us doing other shows that I'm part owner of some radio stations in American Samoa. And this is a little group of islands. You go to Hawaii and turn left and continue on toward New Zealand. And there's the main island is called TWiT. The capital city there is pronounced Pongo Pongo. It's spelled Pago Pago. It's pronounced Pongo Pongo. And they were suffered from that tsunami a couple of years ago. Some folks died, and fortunately some folks died right outside our radio station. Our power was off for days. FEMA flew in generators, and through some pretty good efforts, our station has been able to obtain some permanent generators from FEMA, and we'll have pictures of that in a future episode. We've got a generator at the studio, a generator at each of two transmitter sites on mountaintops. Really hard to get to sites, and the installation of these generators has prompted us to make some real good improvements and better grounding and lightning protection at these sites. So, that's good preparation. If we have another tsunami, we've got backup studios now at one of our transmitter sites, and we've got power, independent power, at the current studio and two other transmitter sites. So this is something that American Samoa has never had, a radio station well equipped with backup power. And two transmitter sites, so we can certainly be on the air if we need to. So that's the kind of prep that I think engineers need to do whenever we can. And honestly, our little station in Samoa, we could not afford to do this without the federal government saying it's important that you guys be on the air. You're the LP1 for the area. You're important to the EAS. We have the I'm sorry, I forget what it's called. We have the blue EAS receiver that is connected by phone to the mainland. So that's the kind of story we're talking about. I'm sorry, am I cutting somebody off? Was somebody trying to get a word in edgewise? No? Okay.
No. Sage Index is the blue box.
That's it. The Sage End, yeah. But it's a special one. It's a special one that the certain stations get. Sorry, I don't know the right words. I need to study up on this. Hey, Tom Ray, let's run over to you. Have you? We didn't get to talk
as long
about
as you don't
beforehand.
run over me.
We were all talking about Curt and his experience before the show. Tom, do you have a war story to tell us for today? A teachable moment that we could all learn something from. Oh, great Obi-Wan, master of radio broadcasting.
Actually, yeah, this is something that happened, and actually I may have mentioned this before, but this happened Memorial Day weekend about 5 years ago. I was up with my brother up in Connecticut, and on the way home, it was about 10 at night, and I was literally 10 minutes from the door, and the phone rang. They're telling me all the readings are wrong on the directional antenna system. And for those watching who don't know about directional antennas, what you do is you monitor the input power, the input current, actually, to the antenna system, and you also monitor what's called ratio and phase. There's a power ratio between the towers, and there's a time delay that the signal arrives at each of those towers, and that's how you generate a directional pattern. Well, obviously, I headed the vehicle south and went down to Rutherford and got down there and took a look at the antenna monitor, and while the readings weren't really outrageous, they weren't good. I mean, they were out of tolerance, but they weren't off scale. So I took a walk. You know, it had rained. We had some lightning. And I went out to Tower 3, which is the closest to the building, and walked in and kind of looked around and sniffed a little bit, because usually if you get hit by lightning, there's going to be something smelling. And everything looked in order in the Tower 3 tuning house. So I walked out to Tower 2. Opened the door, and something didn't smell good. And I was like, okay, something happened here. So I followed my nose, and the way most of the stations in New York are set up, a lot of the AMs, especially over where we are in the Meadowlands, are close together. So what you have to do is you have to detune. Each station detunes for the other stations, so the antennas or the towers become invisible to the other station, so they don't interfere. Even though we're not on site and we're not part of the same station or part of the same antenna system, we could interfere with each other and cause grief. So, and the way we're set up, we usually have metal cabinets, so everything is shielded. Kind of sniffed around the tuning unit. Yeah. Nothing unusual. Kind of sniffed around the trap cabinet. We have traps to prevent the other stations from feeding back in, because a transmitting antenna makes a dandy receive antenna.
Yeah, I bet it does.
Didn't smell anything there. Walked over to the detune cabinet where the detune networks are. Didn't smell anything there. And the output network cabinet smelled. There was something funny. So I opened the door and I'm looking.
Oh wait, Tom, let me get this picture clear, Tom. This is at the base of the tower. You've got like 3 cabinets.
There's actually 4 cabinets at each of our towers.
At each tower, there's 4 cabinets.
Yeah, and there's one. The first one you encounter is as the transmission line comes into the building. The first one you encounter is the actual tuning unit. This is what matches the transmission line to the tower, or to the tower and the other stuff hanging across.
And then the rest of the network. Yeah. Okay.
Yeah. Right. And then you come out of there, and it goes through a set of traps, because there are three major and a couple of other stations that could get feedback into us because of the close proximity. For example, we're right in front of 1010 winds. They're putting an equivalent 160,000 watts in our direction, and we have 3 volts per meter of measured signal at winds on our property. So,
and by the way, just to make it clear, you're using some words that a directional broadcast, an engineer, broadcast engineer, familiar with directional stuff, would understand what you're saying. But a large part of our audience doesn't know what a trap is. And I'm guessing you're talking about an arrangement of capacitors and coils that are tuned such that certain signals are maybe shunted to ground or reduced, and others are passed on through the cabinet. Yeah.
That's mostly correct. It's a series of capacitors and coils that are tuned to form a high impedance. So a signal, let's say at 1010 for 1010 winds, doesn't get back into my tuning unit and doesn't go back to my transmitter. So what it does,
the circuit's it's a low impedance to your frequency. What is it? What's your frequency?
710, and it's a high impedance to 1010. So it's it's effectively like a brick wall. 1010 comes in and goes boom. Nope, thou shalt not pass. It's like the Black Knight in the Monty Python movie.
All right, great.
And then we have detuning networks. What a detuning network does is, of course, when the signal hits that tower, it's going to want to radiate, because the tower radiates. Yeah. And if I re-radiate the signal from 1010 winds, well, they have a specific directional pattern. They can't. They won't be able to maintain that pattern, because I have their signal bouncing off my towers. So what this does is this essentially takes the tower and makes it invisible, is the best way to describe it. To 1010 winds, but it doesn't affect 710.
So a way I like to describe this for folks who I'm trying to describe it to, if you have a tuning fork and you strike it and it's making a tone, and you have a similar tuning fork nearby, it will sympathetically vibrate, right? And
that's
that
correct.
Would be like your other tower. Your tower to 1010 winds, you don't want it to vibrate. You don't want it to pick up and re-resonate. So you dampen any resonance on 1010 or any other stations in the area. And by the way, this is also done, for example, if you have a directional AM directional facility and somebody, this happens a lot, somebody builds a cell tower not too far away from your directional facility, that cell tower might have to get detuned so that it looks invisible or it's dampened. It doesn't resonate or re-radiate your station signal. Because if it does re-radiate, all of a sudden your station is not meeting the specs for places that it's not supposed to transmit. If you have to have a null in this direction or that direction, that null will be filled in by this other re-radiating tower, and you will no longer meet the specs of your license, and it won't be your fault. But you got to go find the problem and fix it. So, okay, you guys all cooperate in that area where you've got several transmitter sites in the near vicinity.
Right, and for those who have never dealt with this before, if you pass a directional AM radio station, and a directional AM radio station is usually, well, not usually, it is defined by more than one tower. So if they have 2, 3, 4, 5, whatever towers, chances are that's a directional. So if you know there's a directional station and take a look around, for example, you see a cell tower fairly close, or you see one of those big steel high-tension towers, power company towers nearby. If you go look at that tower, chances are you're going to see a very thin wire, or several very thin wires coming down and usually going to a box at the bottom, and that's the detuning for that tower. Or that structure. We do it slightly different ways because, I mean, we're out there, we're a little more active than these guys are. But there are numerous ways. I mean, we have detuning skirts on the WR towers. This could be a whole other show, so I won't get any deeper into it than that.
You're right. It could be a whole show, and you can detune things like a water tower with eight pillars holding it up. That's a trick, but it can be done.
Oh, you bet. And but anyway, so we've got these cabinets. So you got the one cabinet that's the tuning network that matches the transmission line into the tower and whatever else you've got hanging across it. You go through the traps, and the traps are the brick wall for the other stations. Then when you come out of the trap cabinet splits in two directions. One direction goes into the detuning cabinet that detunes the tower to make it invisible. The other side goes into into the output cabinet,
right?
Which then feeds the tower. I take that back. I got that wrong. The detuning cabinet and the output of the output cabinet are across the tower. So anyway, I'd have to draw a schematic, but suffice it to say, there's a lot hanging across this tower. So you've got the output cabinet,
yes,
and because of the complexity of the detuning and the traps, we have an output cabinet, and the main purpose of the output cabinet is to get rid of any reactance from the tower. If you look at the tower RF-wise, the tower consists of a resistance, which does the work, and a reactance, which doesn't do any work but causes a grief. So what you want to do is, in our cases, the towers are slightly capacitive, so we have a big fat coil right before the tower that negates, because a coil is the opposite of a capacitor, it negates the reactance on the tower or the capacitance of the tower. So if you were to hook a piece of test equipment up at the input to that coil, you're looking at a pure resistance into that tower. So we've got the coil. There are a couple of vacuum capacitors that form a tuning network. There's what's called an isolation coil, because I mentioned before, you have the antenna monitor, you have to monitor the operating parameters of the towers. Usually on a directional antenna, the ideal thing is to have what's called a sample loop. The sample loop comes down, goes into this what's called decoupling coil. The idea of the decoupling coil is on one side, it's hot because that cable coming off the tower is hot. The other side's ground, so it gets rid of the RF. And then you've got a static drain choke, and its main purpose in life, it's a very, very high impedance at all RF frequencies, but its main purpose in life is to sit there, and if the tower charges up, very similar to if you shuffle across the carpet in the wintertime and touch a doorknob, you're going to get carpet shock. The tower does the same thing, because you've got wind, you've got dry snow, you've got sand or whatever blowing past the tower, and it sits there and electrically charges. And this thing just kind of sits there and drains off that charge, so you don't have something arc over or fire over and trip the transmitter off.
So the static drain choke is invisible to the RF. The RF doesn't care about it. It looks like a big high impedance to ground. Doesn't care about it. But to a DC charge, which is what static is, it just kind of it goes through this coil and just drains off and goes to ground, and that's the end of it.
Okay. So I open the cabinet and I'm smelling this thing, and I take a look at this big fat coil. There's nothing it's not discolored. There's no burn marks. The spacers on the coil are some type of phenolic material. That's not burned. So it's not the coil. So I take a look at the vacuum capacitors. Now, a vacuum capacitor, if you take a direct lightning strike and a vacuum cap explodes, which they do, they don't smell. There's nothing to smell. I mean, there's copper inside and there's ceramic, and that's about it. So there's nothing to smell. Caps look good. Okay. Move my eyes over to the isolation coil. And the isolation coil, well, at WOR, once again, this could be a whole other show, we don't use the sample loops except for testing purposes. So the isolation coil is actually disconnected. It's just kind of sitting there. So it's not going to be the isolation coil. That leaves the static drain choke. Now, these static drain chokes, to get that really high reactance, are wound very tightly. They're about yay big around, and they're wound with wire very tightly. And normally what happens if you take a lightning strike and it goes through that static drain choke, two things will happen. First of all, the whole thing will burn. But second of all, it's like taking a spring and stretching it out to the point where it can't be springy anymore. The thing just goes boom, and all the wiring kind of flies off this thing and sits there in this nice loose arrangement now.
Oh, yeah, okay.
It looks perfectly fine. I was like, the hell? The only other thing in the cabinet is a set of ball gaps. So you got two brass balls for all intents and purposes.
Okay.
There's no other way to say it. That's what they are.
Yeah, you're right. That's what they are.
And they're sitting here. They're sitting there like this. The purpose is if you get hit by lightning, there's two sets of these on the tower. It'll take the lightning and short it to ground because lightning is looking for ground, is looking for the shortest path to ground. And if it makes it to the output cabinet, we have another set of balls there with a gap to hopefully fire that over before it hits any of the components.
All right.
So one side you're sitting on, and I'm going to use this flashlight. You're sitting on a brass, cylinder that attaches to ground. So you've got the ball here, and this attaches. So that's your ground side. Now the other side has a ceramic insulator that's about the same diameter,
right?
But it's ceramic, and it isolates that, which is the tower side, from ground.
Okay.
And I'm sitting there looking at that, going, "Huh?" And I'm looking. I walked outside, scratched my head, came back in. Yeah, I'm still smelling it. Yeah, it's coming from the output cabinet. And I go through the whole routine again: coil, isolation coil, static drain choke, vacuum cap. What the hell? And then all of a sudden I realize the coil and the capacitors are sitting on the same ceramic insulators as the one that's on the ball gaps. But the one at the ball gaps was a different color. And I said, "Oh, huh." Yeah, it's supposed to be kind of a milky, creamy white, and this one was more. It was bordered. It wasn't brown, but it was brownish. It was kind of a tan, and I'm like, that's unique. And I took the pen out of my pocket and I poked it like that. And when I poked it, the thing shattered in about 5 million pieces, and now the ball's hanging in midair. And I picked up the cell phone and called the studio and said, "How do the readings look?" And they said, "Looks great, whatever you did." So what probably happened is we took a lightning strike. It made it into the cabinet. It arced over on the balls, but there must have been a flaw in that ceramic. And when the lightning charge hit it, it arced through the ceramic insulator to ground and created a resistance path. It created a carbon path, which carbon is a resistor. Because let me tell you, those pieces of that insulator were hotter than hell. So there must have been a good couple of kilowatts going through that insulator before I touched it with the pen and it shattered. But it was like, and the smell wasn't the ceramic. On top of the ceramic insulator, there's this teeny tiny little nylon washer. That thing was melting. Yeah. That was the smell. But it's like, I'm sitting there, it's like, what the? There's nothing wrong here. And all of a sudden, I realized.
I'm amazed and I'm glad that you touched that insulator you chose to grab a pen or something to touch it, because I've been in a similar situation to that, Tom, where an insulator was actively carrying a piece of ceramic with a flaw in it, or some moisture, or moisture and a flaw, and now carbon, was actively carrying some RF, and I've touched it with my hand. I'm going around going, ah, whoa!
And I bet your fingerprint is still on that insulator, huh?
Yeah.
Well, we had an FCC inspector come out to a station I worked at once, and the old thermocouple ammeters that were used were actually in the circuit, and the case on the ammeter was hot. Yeah. And the FCC inspectors like to tap the front of the meter to see if the needle's sticking.
Oh, okay.
So he went out there, and I handed him my pen. I said, "Here you go." I said, I know you're going to tap it. I said, "Don't use your finger. The case is hot." Yeah. He went like that. His fingerprint is still on that meter.
with the RF got him and burned his skin to the...
Oh, it bit him. He didn't do it again at the other tower.
Wow. So that's what would you walk away with teachable from this experience, Tom? I mean, here's what when you first started talking, I thought, I know where this is going. I thought, what you got to do to solve a problem like this, you got to go look at stuff. You got to go walk. You got to open stuff up, have a look, use your nose, use your eyes, use your ears. And
don't take anything for granted, because I did not suspect that insulator until all of a sudden it hit me. It was a slightly different color than the other ones, and it wasn't a major change, but it was slightly different. And that's when I looked at it and said, that looks funny, and that's when I decided to touch it
with your pen. So thank you. Thank goodness.
So don't take anything for granted when you're looking at this stuff, and it may be something you wouldn't even think is the problem.
Yeah. Wow. Amazing. All right. That was a great story, Tom, and a teachable moment. I sure appreciate that. Let's spend the rest of the show now talking with our guest, Curt Yengst. Hey, Curt, are you still with us, Curt?
Well,
good deal. Let's hear about your experience, whether it was harrowing or not. I don't know, but maybe you can kind of jump us back into the story now. What prompted you guys to do whatever preparations it was that you started doing? Kind of carry us through, start with the premise and begin taking us through the story. And I might interrupt you, or Chris might, or Tom might, to ask a question.
The whole preparation thing started actually back in 2006 when we had the nor'easter, where the flooding really wasn't severe. Basically, the road out in front of the campus was flooded. The basements on the campus were flooded. The parking lot was flooded. So the building pretty much emerged unscathed, relatively speaking. But what happened was we basically lost access to our studio. Our studios were on the second floor of the building. So it would take, if the water ever got that high, I don't care anymore,
Yeah.
But what happened was we had no access to the campus. We couldn't get to the place. Fortunately, the station's automated, and we did have some kind of a VNC remote connection to our studio, so we could at least go in and kind of get it automated to the point where it would fly on its own for as long as we needed it to. The problem there is that it definitely ends up sounding like nobody's home. And so we were kind of like, okay, this isn't good. So we kind of scrambled up to our transmitter site, and somebody had grabbed a little Mackie 1202 mixer and a Shure SM58. And we were going to try to Rube Goldberg something where we could at least get some kind of live information on the air. And that failed miserably because we weren't prepared. So, of course, I don't have to tell you that the following Monday there were meetings.
Again, this is back when that nor'easter happened. What was it? 2006.
This is 2006. Now, of course, we all sat around and did all the Monday morning quarterbacking. What could we have done? How do we keep this from happening again? And we started to look at on the back of our transmitter building. Is this little? We were at the time kind of calling it a shed. Really, it was a concrete room built onto the back of the building. That at the time we were really using it basically as a storage room. It was a catch-all. Anytime we had a piece of junk, something around, we had no place else to put it. That's where it ended up. It was a bare concrete room, not much bigger, probably actually smaller than a one-car garage. Dirt, bugs, spiders, Every once in a while, you'd find a shedded snakeskin in there. It was just it was a mess. But station management took a look at that and said, we can see possibly doing something with this in terms of a backup studio. Now, about this same time, we were looking at the current main studio, main control room, and it was in dire need of a renovation because it was something that this particular control room had been built sometime in the early 70s, back when we had a completely different format. It was all taped to transmitter. The guy just gave the weather like once an hour kind of a thing. And that's about all you could get in there was maybe one or two people. You couldn't really do a morning show from in there. You couldn't really have guests in there. And it was sort of antiquated technology at the time. So we decided, all right, we need to get this renovated. Well, where are we going to broadcast from during the 4 to 6 weeks that we're renovating our only on-air studio? And so we decided, all right, let's kill two birds with one stone. We're going to build an emergency backup studio at the transmitter site. And once that's ready to go, we'll move operations to there. Then we'll come back to the campus and renovate the studio. And this was, by now, it was about 2008. I mean, just to give you an idea how much time it took to come up with the funding and all that sort of thing. So we went into that shed on the back of the transmitter building, cleaned it all out, gave it a coat of paint and some woodwork. And I think, Chris, you got a picture of the we lovingly refer to this windowless concrete room as the bunker, because that's exactly what it feels like when you're in this thing. So
Kirk has
I
the
think
picture with it's your midday
Kirk
host.
has, okay, yeah.
Picture with the young lady in the windows room.
Yeah, that's the one.
That's it.
Mm-hmm.
All right.
So if you want to go ahead and put that up, that'll give you an idea what we're talking about that we now have on the back of the transmitter building. We tied it into our air chain through a Broadcast Tools DMS3 switcher. That one side of it is fed from our main studio from our STL. The other side is fed directly from the bunker. And it's got all the comforts of home. It's got a smaller version of the console we use in the main studio. It's got a couple CD players. It's got the Vox Pro system. It's got a 6-line Telos telephone system, enough mics for an announcer and 3 guests. We even have satellite TV up there. So we have basically everything that we have in our main studio just scaled down a bit. And what we do is we use Audio Vault as our main as our automation system. We actually have a standalone Audio Vault system in the bunker that is tied in to our main Vault system back at the studio via our STL. So anytime we add audio to the main system here, if we add a commercial, if we add songs, if we add any kind of new imaging, it automatically gets sent to the bunker. And that system is running constantly as a hot standby. Not only does it provide a hot standby, it also provides off-site backup for our entire library. So it covers us that way as well. It takes us, a few minutes if we wanted to. We basically, if we had to go switch to the bunker, it's just a matter of calling up the Burke remote system, telling it to switch the studios. And then we call. There's a website we go to where we can port our 800 number to our studio line over to the phone lines up at the bunker. So within about 20 minutes, we can get everybody up there and start broadcasting right from there. Actually, as far as broadcasting, we can start broadcasting almost immediately. It's just a matter of making the switch. That system is always running in the background.
Curt, let me ask you one question about what you guys did to build and design this bunker. That's a nice looking studio, and I've been involved with stations that have built backup studios at the transmitter site, and the effort was, the end result was not nearly as nice as the picture that you showed there, and with not as many amenities, to be sure, something that you wouldn't want to be in for more than a few hours. How did you persuade management, or how did you come to an agreement that we're going to make this A, it's going to be a backup. B, it's going to be nice. It's going to let us do all the programming, or at least most of it that we do from our regular studio. And guess what? We're also going to use it for, like as you said, as backup facilities for our important programming, whether it's programs or commercials, whatever it may be. How did you kind of get that done and get the persuasions made that needed to be made?
Actually, we didn't have to persuade them. They were the ones that wanted it that way.
Oh.
They didn't want just a little mixer sitting on a table in the engineer's, workshop up at the transmitter. They actually wanted something that was going to be comfortable, because they knew in some cases somebody may be operating out of that for, in the case of Hurricane Irene, we ended up operating out of there for about 6 weeks.
Whoa!
I mean, it was quite a haul up there. I mean, and again, like even when we were renovating the studio back in 2008, we were you're talking about a few weeks at least that they were operating from that space. So it had to be comfortable. You gotta have it where people are not so thoroughly disgusted with it that they stop showing up for work. The only drawback is up at our transmitter site, we have no running water. So obviously there's no toilet facilities. That makes it a little iffy. If we know we're going to be up there for a day or two, we try to avoid sending the ladies up there. If we know we're going to be up there for a while, then the chief engineer calls and orders a porta-john. And then we just park it behind the building. And it's you do the best you can. What was really great with Hurricane Irene, we knew it was coming. So we knew what we were going to need. We got what we needed in terms of extra stuff, got it out of there, got it out of the building, and we moved up to the bunker. We already knew we were heading up to the bunker, so all the preparations were made. Actually, our chief engineer made the switch to the bunker the night before the storm made landfall in New Jersey because we saw it coming. So everything was already set. The morning crew just had to show up and unlock the door and go. And but then we noticed, okay, we didn't have ready access to our main studio facilities at the time because after the hurricane, everything was flooded. Everything was pretty much wrecked. All the first floors of the buildings had to be completely gutted. So they were kind of limiting access to these buildings. Well, we quickly realized that we didn't have a whole lot in the way of production facilities that we could get to. And yeah, here's the picture of this is the front entrance of the chapel building where our studios were located. We were on the second floor. Now, just to give you an idea how deep that water is, you see how the water comes up about halfway up the front doors there.
Sure.
The bottoms of those front doors are about 5 or 6 feet off the ground.
Oh. So you go up some steps first to get
you have to walk up
doors.
about 6 or 7 steps just to get to those doors.
Yeah.
So that'll give you an idea how deep that water is. Okay. Well, you can see it goes to the window sills. You see the windows. That's the first floor. So basically, the entire first floor was a total loss. The basement, same thing. Fortunately, because we were on the second floor, the only real equipment loss, as far as we were concerned, is our backup studio generator. We had a complete backup power system for our studios.
By the way, I just want to point out something in that photograph, if Burke could run back to just for a moment. You've got a problem at your radio station when the picture of the building includes a picture of a trolling motor's propeller.
Yeah.
In the bottom left of the picture.
Yeah, we were calling it.
It's just never good.
Venice on the millstone.
There you go. I'm sorry, Kurt. I just had to point out the propeller. You don't often see the picture of your radio station. We actually we had a backup power system at the studio, complete backup power system, consisting of it was like about a 12 kilowatt UPS battery backup for the entire studio facility, coupled to a 7.5 kilowatt generator that was located on the first floor of that building at the back of the building in kind of a cubbyhole room under the chapel platform. And that generator was the only casualty as far as our studio equipment was concerned. The problem again, it came down to access. We couldn't get to it. What good is
millions of dollars in broadcasting equipment if you can't get anywhere near it. So again, this is why we had the bunker. But then we started to realize we didn't have a whole lot in the way of production hardware, and even if we did, we had no place to put it. So what we ended up doing, when we got access to the building, limited access to the building, Ron Habegger, my chief engineer, and I ran over there, and we grabbed a couple of production workstations and a couple of mixers and just kind of a few things, enough for a couple of rudimentary production workstations. And we were going to bring them back to the transmitter site, but we quickly realized that we have no place to put these things. The only other space other than the bunker was Ron's office and the room where the transmitter was. Well, you're not going to be cutting voice tracks in front of a 14 kilowatt transmitter. So what happened was, I guess one of the announcers happened to be talking about it on the radio. One of our listeners from down near, I think it was Tom's River or Jackson Township, kind of the southern end of our listening area, heard what was going on. He's got a 30-foot travel trailer, RV travel trailer. He towed it up to our transmitter site, parked it on the site. Ron and I ran electrical cables out to it, Ethernet cables, got it hooked up to our setup, tied it in with, networked it with the bunker, and set up the two production workstations in the trailer. Basically, in the little kitchenette, there was a workstation sitting there. We brought in a folding table and set up another one right next to it. It had a full kitchen. It had a full bathroom. It even had beds if you wanted to take a nap. I had all the comforts of home right there in that trailer, and that became kind of the production studio. And it was far enough away from everything. It was quiet. So we could actually record and produce things there for a while.
Ah, okay, all right.
So that kind of thing helps. It definitely was a morale boost, I can tell you that, because after a while, as it started to get late in the year, it got back to about November. The owner of the trailer had to come and get it back because he needed to winterize it. And I can tell you that as soon as he winterized that thing and pulled it off the site, everybody was crying to go back to the campus. By then, the mess had been cleaned up, and fortunately, we could move back to the campus and start broadcasting. About November, just before Christmas, I think it was, we started broadcasting from the campus again, from our original location. It was kind of depressing. Every time you'd walk in the building, you had to go through the first floor up the stairs to get to our studio, and you had to look at the damage that the flood had done to the building, plus the damage that the mold abatement crews and the cleanup crews had done. They had to gut the entire first floor. I mean, hardwood floors came up, drywall came off. Anything that got in any way touched by water was just pulled out. And so you felt like you were walking into like this gutted, abandoned building. Kind of felt like a war zone almost. And then you go up the stairs and there's this really nice, beautiful studio. And, but then management said, okay, this is not going to fly, because it's not just a question of if we're going to get flooded out again, but when, because obviously this is where we are. These 100-year floods are not happening every 100 years now. We got Floyd in 99. We're kind of seeing like a 10-year pattern here. So they started to really look into broadcasting from someplace else. And so this is where we started the search for new studio space. And long story short, we met the folks at Village Office Supply in Somerset, New Jersey. They're about 2 miles up the road and about another 100 feet above sea level.
Oh, good. Yeah.
And so and it just so happened about a couple of years ago, they had laid off about 50 employees, and had they laid off some, and then the others they'd folded into other departments. So they had about 8,000, 9,000 square feet of office space sitting on their second floor, empty. And they were going to basically just kind of sit on it. They weren't really considering renting it until we presented our needs. And then they said, yeah, come on down. And long story short, we signed a lease in January and spent the month of February moving in. And right now I'm sitting in the new main control room, a lot bigger and a lot roomier than the other one, even after we had renovated it. All the equipment from the old studio was just picked up and shuffled over here. We picked a week when we were going to move, and we sent everybody back up to the bunker again for about a week while we made the switch over. And fortunately, by then it was early spring. We had kind of an unseasonably warm winter, so February was feeling more like spring than winter. So there wasn't too much complaining about having to go up there for another week, but everybody kind of, they understood the situation, so we got it done as quickly as we could, and here we are. As far as lessons learned, like I said, most of the lessons we learned long before Irene, fortunately. So, the only other thing that I think the biggest complaint was that it just having to be up at the bunker for so long. When you're operating out of temporary facilities like that, it's like with anything. If your house burns down and you have to live in a hotel for 6 months while they rebuild it, I can't imagine. I can't imagine it would be. It's going to get old fast. It's one of those things.
Yeah. Camping out's okay for a night or two, but not for 6
exactly.
Oh,
but we're not living out of suitcases anymore.
So your station is in New Jersey. Now, I was looking at your coverage map, I think on radio-locator.com, and you guys do get into New York City. You certainly cover the southern tip of Manhattan, don't you?
Mm-hmm. Yeah, Manhattan, Staten Island. We've gotten calls from listeners in Queens, Brooklyn. By then, they're few and far between because you're getting obviously out of our coverage area. We get as far west as East and Allentown, PA area. It's pretty decent coverage.
And what I'm getting at is this: in some ways, when I'm looking at those pictures that you presented, in some ways, your station to me kind of feels like a medium or even small market station with the friendly atmosphere, but then and with not grandeur facilities, not a whole floor in a Manhattan office building or even a Newark, New Jersey office building, but in other ways, you're covering a very populated area. You've got a big audience. Do you find any of your engineering decisions based on, hey, we may not be a Manhattan Island, New York City radio station, but we serve a lot of the same people. We have a lot of the same audience that a big city station would have. First of all, is my impression wrong? And second of all, how does that affect your engineering decisions in terms of staying on the air and audio quality and this kind of thing?
No, you wouldn't be wrong about it at all. That's exactly how we look at it. We also look at it that because of our format, we're kind of in a niche. There aren't a whole lot of other contemporary Christian radio stations in the area, and the ones that are outside our coverage area. So for say people in Middlesex, Union, Somerset County, getting up into North Jersey, we're kind of it as far as what they want to listen to. And it's also very important. We do have a very good relationship with our listeners. So it's very important to us in a disaster situation to sound like somebody's here.
Ah, yeah.
And that's kind of where the mentality of the bunker came from. We wanted to have, it wasn't just a matter of keeping a signal on the air. It was, we got to keep a signal on the air, but we also have to sound like we're actually here. We're still here. We're still taking calls. We're still talking to you. And, as long as it's kind of like some, as long as we're here, it doesn't matter where here is,
Gotcha. Hey, I just realized we have done almost the whole show, and I have gotten a word in edgewise for our show sponsor. So we're going to continue our conversation. We've got a couple of wrapping up comments from Curt. I think Chris Tobin may have one more question or may have a question. I haven't let him get a word in edgewise, and maybe Tom Ray does too. But I want to tell you about our sponsor for this episode of This Week in Radio Tech. Yeah, okay. The place that I work for makes some really cool stuff, and one of the products that we came out with at the NAB show here, and we're shipping it now, is the Telos ProStream. Maybe Burke can get a picture of that up on the screen here. If you want to go to the web and see about this product, it's at telos-systems.com/ProStream. ProStream, PROSTREAM. Now, of course, you can get some software. You can get some software for free. You can get some software for some money that will do some audio processing and will encode audio into streaming audio, MP3 or AAC audio, and several other formats too are possible. Well, if you don't want to deal with a computer to do that, a beige box or a server-based system, it's possible to do this with an appliance, and that's what the Telos ProStream is. It's an easy-to-use appliance that will take audio in either analog or via LiveWire. There's a LiveWire jack on the back. It's got an Omnia 3-band audio processor built into it. So it's got wideband AGC, 3 bands of multiband audio processing. And by the way, this processing is optimized for streaming, not for AM, not for FM, not for television broadcasting and that kind of modulation, but for coded audio. And then it's got a look-ahead limiter that's really sweet, that really pumps the level up and gives you very sure levels without any clipping at all. So that's the Omnia processor that's inside. And then inside the box is an encoder. You can encode the audio into MP3, AAC, AAC low delay. There's also HEAAC, and the codec that our friend Greg Oganowski always talks about, HEAAC V2, which lets you do really good entertainment quality streaming at about 56 kilobits per second and even lower bit rates from that. We've just added in beta, and I think this will be available in the release version pretty soon, a new version of software that includes 2 different encoders. One audio processor, but you can encode at 2 bit rates and even 2 different algorithms if you want to. The box also features the ability to push your stream to up to 4 different Icecast or Shoutcast servers. Maybe they're geographically diverse. So if you need to, ship a stream out to San Francisco and ship another stream to New York and ship one down to Buenos Aires and ship one to Mumbai for streaming servers in those locations, you can do that. These push streams are all built in. One more interesting thing, the ProStream now has the ability to generate multicast streams. So if you're in a campus situation or a large building or you just need to get streaming out to a whole lot of people that are on a common network, the ProStream now has the ability to do multicast streaming. So you can let your network do the work of reproducing the stream, and you don't have to use a stream server per se for that function. So check it out on the web at telos-systems.com, the Telos ProStream, the appliance that does audio processing and stream encoding from Telos. Thanks very much to Telos for sponsoring this episode of This Week in Radio Tech. Okay, Curt, hey, let's pass things over to Chris Tobin. Chris, sorry to hog the show here as I usually do. You had a question or comment for Curt?
Yeah, question. I'll pepper it with some props first. We're speaking of being prepared for disaster or disaster preparedness and whatnot, and you're talking about Audio Vault and keeping it up to date at the transmitter site. And, I keep me being a crazy ham operator as well as other things I've been doing, working as a broadcaster with the OEM folks, keep different two-way radios fully charged and properly channeled with frequencies for stuff, just for that moment. When you have a backup site like the bunker, which technologies are you using to keep the bunker up to date, I'll call it, while you're not using it? Say, normal operations are out of the new facility in Somerset, and the bunker is offline, but still keeping a mirrored, if you will, access to important stuff for broadcast so that you can make that move in 20 minutes or so and be up and operating. Like your STLs, are they wired, wireless? Are you using, any kind of special MPLS IP circuits to get bandwidth up there for your Audio Vault? And then, what type of connectivity do you have up there so that if you have to sever ties with the studio, you stay connected and can still function, control, and do what you need to do at the transmitter site?
Yeah, great question. What we have up there, basically the way it works is we use fiber optic T1 lines for our STLs. They've proven very reliable over the last probably at least 10 years we've been using them, probably longer. I know that we were using them when I first got here as assistant engineer. That's what we were using. And
when I can only think fiber optic. Were they installed as part of a cable service or Verizon or whomever?
No, just
telecom?
dedicated Verizon dedicated T1 lines.
So they actually put fiber along the poles or got you into their fiber network and up to Martinsville.
Exactly.
Wow, lucky you.
something to that effect. But yeah, we have three T1 lines that go up there. One of them carries the digital audio for our main channel. The other one carries digital audio for one of our two additional HD channels. The other one carries additional audio for one of the other HD channels, plus a local area network data connection. Albeit it's a narrow pipe, it's a low bandwidth connection, but it's a connection. So that the bunker vault, for lack of a better way of putting it, the bunker vault is connected to our main studio vault network as if it were sitting in the rack with the other vault equipment. And Audio Vault's NF server program actually takes care of seeing to it that the audio gets sent back and forth. So if we add a commercial here, we add a song or an imaging spot, Vault is going to copy that back and forth between the two local servers. It also sends a copy up to the bunker. So as long as that thing is on and as long as it's running, which it always is, it gets automatically updated every time we add something, so that it's always got the most current library of what we have: music, commercials, spots, anything else that we add. So that's basically how it's done, just via T1 line, and then gets constantly updated.
I'm curious.
The studio,
yeah. Oh, go ahead. Go ahead.
No, I was going to say the studio up there is always on. It's always powered up. It's always on. So if I had to, in fact, sometimes what I'll do, once every couple of months, I'll need to come in here late at night and just do some studio maintenance or something. And what I'll do is I'll switch us to the bunker, just so I don't have to worry about knocking us off the air accidentally. I can go ahead and just tear the whole console apart if I wanted to, and as long as I've got it back up and running before the morning show crew shows up, I don't have to worry about knocking us off the air because we're running from the bunker while I'm doing maintenance here. So it serves kind of three purposes then. It's an off-site backup, it's an emergency studio, and it's a standby studio for after-hours maintenance.
Excellent. Now, as an architect of emergency evacuation plans I've had to do in my previous jobs, how do you guys prepare yourself in the event that, say, there's a need to relocate the studio ops to the bunker, and you're not available, and the chief is not available for whatever reason? How do you guys handle studio ops, say a operator on duty, DJ or whomever, getting switched over up to the bunker and operating from there? Or do you have a plan?
Chief engineer or I can switch to the bunker from our cell phones if we have to. We don't actually have to be on site either here or there. We can do it. I can either do it from my cell phone or I can do it from my laptop. As far as when we send the personnel up there, usually the first step in the process is actually getting the switch made to the bunker. So we get the bunker on the air. Then at least we're playing music. It's going to be automated for a little while because you got to get personnel up there next. While we're getting the personnel up there, we're porting the 800 number over to that phone system. That's a process that usually takes anywhere from 15 to 30 minutes, depending on how fast our 800 number service can process the order. And then it's a matter of we send them up there. Essential personnel are usually the first ones on site, and they all have keys to get into the building.
Excellent. Well, it sounds like everything is well thought out, and the technology is deployed are the latest and keeping you current, so you're probably no more than 10 or 15 minutes behind anything if you had to go up to the bunker and operate as far as commercials, spots, that is, and probably music or anything else.
And if we had to sever ties with the main studio, we also have high-speed internet up there. We have Verizon Fios for high-speed internet and cable TV. So we're not completely cut off from the outside world. We also, obviously, the transmitter site also has a complete backup power system. We have a very large UPS that can handle things for a few minutes, which is more than enough time for the big diesel generator to get started. And that generator can basically power the entire site as long as we can feed it diesel.
I'm curious. I know I've done this in the past. How often do you cycle your generator once a week with load, or Do you once a month? I mean, how do you? Do you have I'm sure you have a procedure to just keep an eye on things so that in the event you have to move to the bunker, you're prepared. Just curious.
Yeah, we have
station of your size.
Once a month, I do regular audio vault maintenance anyway, just kind of checking things out at both ends, main studio and the bunker. Also, the generator does get exercised once a week. I'm pretty sure the once a week exercise is without load, but periodically we do exercise it with load. So yeah, everything gets the once over on a pretty regular basis.
Nice. Well, I'll tell you, it sounds like you're well thought out. You and the chief are doing a nice job. And from what I can see in that studio, it looks really good. The next time I'm passing through Somerset, and I know in advance, I will definitely give you a call. I need to check this out.
Yeah. One of the things we were talking about, one of the things I was discussing with one of our on-air personalities, actually just this afternoon, talking about disaster preparedness and the importance of keeping the radio station on, even if you're not necessarily a news or information-oriented station. In a disaster, you become that, even if it's on a limited basis.
Absolutely.
Even if it's just information in terms of just taking calls from listeners, being able to do that. What I found when I was riding out Hurricane Irene in my at home, I was listening to the radio, and it occurred to me that okay, I've got in my hand here this little portable transistor radio, little Radio Shack radio with a 9-volt battery in it that will keep me connected to the outside world for probably a week at least before that battery starts to die. An iPhone is not going to do that for you. You're certainly not going to be watching television. When the lights go out, you're not watching TV. You're not surfing the web at home. I'm talking about people at home. You're listening to the radio.
This is true. Well, I would say 2 words to answer your question as to what happens not being a news station or news person and your radio station is in a disaster environment. It's brand loyalty. Listeners know where to go, where they're accustomed to first. They'll find out if you're doing the job of informing them. If they don't, then of course they'll scan the dial for somebody else that does. But you're absolutely right. I mean, that's a great way to look at it, and it's nice to see that you guys are doing that. Because I've always said in many other of our netcasts that radio is still a local medium no matter how you look at it. And if you're smart about it and treat it as local as just being a one-on-one, when times of trouble occur, you will be the first sought out. And if you do the job right, you'll be the ones they remember when the time comes.
Hey, that is the truth. That is the truth. That's a whole war story there. Hey, Curt, we got to get out of here. I appreciate very much you spending an hour of your time with us and recalling for us this getting prepped from that nor'easter in 2006 and how it helped save you during Irene several years later. So thank you for being with us on the show. I appreciate it.
Thank you. Thoroughly enjoyed it.
All right. Curt Yengst has been our guest. He's the assistant engineer at WAWZ in New Jersey. Say the name of the town you're in.
Zarephath is the city of license.
Zarephath. I was reading it. I thought, how do you say
it's a mouthful.
yeah. And hey, we do have to zoom out here. I want to thank our sponsor, which is Telos Systems and the Telos ProStream. Easy. Appliance-based streaming. You put audio in, you get a stream out. And also I want to thank Chris Tobin, who's been with us as one of our co-hosts. Chris, thanks very much, and appreciate you suggesting that Curt be our guest.
Oh, you're welcome. I enjoyed it. I've done the same stuff he's done, and I thought it'd be nice to share with others. So thank you.
And also Tom. Tom, are you still there?
Yeah, I'm here.
Okay,
I'm just listening and learning. That's all.
Tom, thank you for being with us as well. I appreciate your war story about that insulator and the RF and using your eyes and nose to solve the problem.
Next time we'll talk about using other body parts.
Next time you'll use your head, right?
Ouch.
Well, possibly. Anyway, but everyone, thanks for joining. Thanks for having me. Thanks for joining us. And yeah, I'll be here next time around.
All righty.
Back to you.
And thanks also to Burke McQuinn back in Petaluma, California, for switching our show and keeping us all on our toes and asking a few salient questions here and there himself. Appreciate that very much. You be sure and join us next week for This Week in Radio Tech. On upcoming episodes, we've got good guests and we've got good chatter all coming up in future episodes. So please tune in every Wednesday at 5 p.m. Pacific, 8 p.m. Eastern Time at twit.tv and press the Watch Now button. Or live.twit.tv will get you there, too. All right. Thanks again, everybody. We'll talk to you next week on This Week in Radio Tech. Bye-bye.